In section 3, we are going to talk about the graphs of sine, cosine, secant, and cosecant. So these graphs are based on the unit circle, which we know has a radius of 1. And so that's what our y, the biggest y coordinates are that we have around the circle. So if you would like to put a 1 and a negative 1 on your graph, that'll be the highest and the lowest that we go. The other values we need are 0 and pi over 2. We're going to do all the axes, so pi will be next, and then 3 pi over 2, and then finally 2 pi. So these are periodic functions, which means they repeat, and so a period is the length of the smallest part that repeats. And then the amplitude is the distance from the middle of the graph to the top or bottom of the graph. So if you remember, at 0 degrees or 0 radians, either way, the y-coordinate is 0. And then at pi over 2, the y-coordinate is 1. At pi, that's over on the x-axis, so your y-coordinate is 0 again. And then at 3 pi over 2, your y-coordinate is negative 1. And then 2 pi is back all the way around the circle, and so your y-coordinate is 0 again. So this graph right here is one period of the sine function. And so this repeats itself. It keeps going on and on forever in both directions, left and right. So the way I remember the sine function is it makes a hill first, and then it makes a valley. So you make a hill and then a valley. And so the period of our graph is 2 pi, that's the length of one section. And so we're going to throw in some extra letters, an A and a B. So the period is going to be 2 pi divided by the absolute value of B. The amplitude is A, so in our case we just have a 1 sine t. So the amplitude is 1, that's 1 up from the x-axis. The way you get your left-hand starting point when you throw extra numbers in there is you take the bt and set it equal to 0. And then the way you get your right ending point is you do the same thing, but you set it equal to 2 pi. Your domain is all real numbers. And the range is only between -1 and +1. So we're going to talk about reflections. If you put a negative on the outside of this, that's going to flip it vertically. So instead of making a hill and then a valley, it's going to make a valley and then a hill. Same with if you put a negative on the inside, that flips it side to side. And so you'd have to start backwards. So the hill would be on the other side of this, so it would have to come in making a valley and then a hill. So actually it does not matter where you put the negative sign in this case, it's going to flip it to be a valley and then a hill. And so in this case our symmetry is odd.